Hello. So today we're going to be looking at identifying congruent angles. We'll be using some theorems and postulates in order to make that happen. So the first theorem is the right angle congruence theorem. What that says is that all right angles, which are 90-degree angles, are congruent to each other. Any 90-degree angle you have in the whole world is equal to or congruent to any other angle that is also a right angle. The next two talk about relationships with complements and supplements, and I have one small typo here that I'm going to fix. This should say complementary, but we'll get there in a second. So the complementary supplement or congruent supplements theorem, wow, that's a mouthful, says that if you have any two angles that are supplementary to the same angle or two congruent angles, they are congruent. I'm going to show you why in equation form this is true using this picture here and this sentence that's next to it. So they say measure angle 1 and angle 2 are supplementary. We know that supplementary means they add up to 180 degrees. So in equation form, we can say measure of angle 1 plus measure of angle 2 equals 180. But then they also say angle 3 and angle 2 are supplementary. So measure of angle 3 plus measure of angle 2 equals 180. Since both of those equations are equal to 180, I can set the two left-hand sides equal. I can say measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus measure of angle 2. And then if I wanted to simplify this, I could subtract measure of angle 2 from both sides, and that would cancel on both sides. I'd be left with measure of angle 1 equals measure of angle 3, and if two angle measures are equal, then that's the same as saying that angle 1 is congruent to angle 3. So that's why that one works. Don't always trust pictures. You can kind of tell from the picture that angle 1 and angle 3 look similar in size, but sometimes pictures aren't to scale. 2.5 is basically the complements version of that. Complementary angles add up to 90 degrees. So we can do this one very similarly. Angle 4 and angle 5 are complementary. So measure of angle 4 plus measure of angle 5 equals 90 degrees. Also, 6 and 5 are complementary. So measure of angle 6 plus measure of angle 5 equals 90 degrees. If I do that slick little trick like I did last time, since they're both equal to 90, I can say measure of angle 4 plus measure of angle 5 equals measure of angle 6 plus measure of angle 5. I'm not going to show the work as thoroughly this time, but if I subtracted measure of angle 5 from both sides, I'd end up with measure of angle 4 equals measure of angle 6. Another way we can say that is that 4 is congruent to 6, which is exactly what they were setting out to tell us here. Next thing we're looking at is actually a postulate. It's a postulate involving linear pairs. So as a friendly reminder, if you have two angles that form a linear pair, that just means together they make a straight line. And when two angles together make a straight line, they are supplementary. They add up to 180 degrees. So you can say, okay, angle 1 and angle 2 form a linear pair. You can just tell that by looking since they make a straight line. That means that measure of angle 1 plus measure of angle 2 equals 180. A lot of times we use this in conjunction with the congruent supplements theorem. Last theorem or postulate we're going to look at is with vertical angles. Remember that vertical angles share a vertex. Any two vertical angles are congruent. I think of vertical angles as being kind of opposite or across from each other. So in this picture, angle 1 and angle 3 are vertical angles. Since they are vertical, they are congruent. Also, angle 2 and angle 4 are vertical angles, so they are congruent to each other. Notice that I use different ways to mark each of those angles because they are not necessarily congruent to each other. It's not that all four are the same measure. You have two sets of two that are congruent to each other. What we actually want to do today is be able to look at a diagram and say which angles are congruent to each other in that diagram. We'll also be able to find missing angle measures if we're only given one. So in these first two examples, we want to say all of the pairs. I'm going to make this a little bit bigger so it's easier for me to write. Find all of the pairs of congruent angles in the picture. There might only be one pair of congruent angles. There might be multiple. So let's start with this one with these three at the top. So we have angle FGH, We know that that box means that it's a right angle or 90 degrees. The next picture almost looks like a right angle, but let's double check the math since they gave us the two smaller angle measures. 45 plus 44 is actually 89 degrees. So it looks like a right angle, but it's actually 1 degree off. Let's do the same thing with WXY and YXZ. 58 degrees plus 32 degrees gives me 90 degrees. So this one, WXZ, the bigger outside angle, is also 90. So the only two congruent angles in this first diagram are angle FGH, which is the one that was marked as a right angle, and then the bigger outside angle here, angle WXZ. Remember to be careful when you're naming your angles. You want the letter that's at the vertex to be the middle letter. None of the smaller angles are congruent to each other. We can see that very clearly because we're given exact angle measures. So just those two angles right there are congruent. The next one doesn't give us any angle measures, but we can do it very similarly if we read our sentences carefully. So first sentence says that angle ABC is congruent to angle CBD, supplementary to angle CBD. So they're going to add up to 180. I'm going to write that as an equation. Measure of angle ABC plus measure of angle CBD equals 180 degrees. Next sentence also talks about supplementary. It says that measure of angle CBD and measure of angle DEF, since they are supplementary, equals 180. Using that trick that we used earlier, since these are both equal to 180, I can set the two left-hand side equal to each other. So I can say ABC plus CBD, angle measures, equals measure of angle CBD plus measure of angle DEF. If I were to subtract measure of angle CBD from both sides, it would cancel on both sides. Boom, boom. I would get just measure of angle ABC equals measure of angle DEF. Another way of saying that is that ABC is congruent to angle DEF. So I'm going to mark that in my diagram. ABC is this angle here. DEF is this angle here. So those two are congruent to each other. Now, what else can we say just by looking at the picture? Well, we can see that angle ABC and angle CBD, we can see that those are a linear pair. And another way of saying that is this top equation here, they're going to add up to 180. Also, by looking at our picture, we can say that angle DEF, this one right here, and angle FEA, they are going to form a linear pair. So I don't have an equation for that, so I'm going to write that one out real quick. Angle DEF measure plus measure angle FEA. Since they're a linear pair, they are supplementary, they add up to 180. Now, if I look at that equation that I marked with the kind of maroon colored star and this one I just wrote in purple, it looks like I'm not going to be able to do anything clever and get something to cancel like I did here at the red and the green. But we know something. We know that ABC and DEF are congruent, so I can substitute one for another in equations. So what I'm going to do here, I'm going to try to mark this up with pretty colors so we can see things very clearly. Since ABC and DEF are congruent to each other, I can just pick one. I'm going to use DEF in both equations. These two are both equal to 180. So I'm going to replace ABC with DEF, measure of angle DEF plus measure of angle CBD equals, let's go to my other equation, measure of angle DEF plus measure of angle FEA. If I subtract DEF from both sides, it's going to cancel. I'm not going to show that because we've done that now a few times. And so that's going to tell us that measure of CBD is equal to measure of FEA. So that means that this angle right here and this angle right here are the same. Since they are the same measure, we can say that they are congruent. And so those are the only pairs of congruent angles in that picture. The last thing we're going to do is, you'll have some of these on the homework. They will give you a picture something like this with 4 angles in it. They'll give you just the measure of one angle. They want you to find all the other ones. So they're telling you here, okay, angle 3 measures is 128. Now, think about the relationships you have going on here. 1 and 3 are vertical angles. They're going to be congruent. So since measure of angle 3 is going to be equal to measure of angle 1, I can say that measure of angle 1 is 128 degrees. And again, that's because they are congruent, because they are vertical angles. What other relationships do we have going on? So we have, let's start with angle 2. 2 and 3 make a straight line. They're a linear pair. So I'm going to say measure of angle 2 plus measure of angle 3 equals 180 degrees. But we already know what measure of angle 3 is. We know that that's 128. So to figure out what measure of angle 2 is, I just subtract 128 from both sides. So I get that measure of angle 2 is 52 degrees. So this guy right here is 52 degrees. And then you can draw your last conclusion one of 2 ways. You can do the same sort of equation that we did right here with 3 and 4. Or you can just notice, hey, 2 and 4 are vertical, so they're going to be congruent. So measure of angle 4 is also 52 degrees. On your assignment, you'll be given the same angles, the same picture, but different angle measures multiple times. You'll have to kind of reset from one problem to another. That is it. Hopefully now you're getting really good at finding congruent angles in diagrams. Have a fantastic day.